In Azure App Service, implementing certificates and TLS is essential to protect data in transit and establish trust with users. By encrypting communication between clients and the server, TLS helps prevent eavesdropping or tampering. Certificates validate the identity of the web application domain, assuring users that they are visiting a legitimate site. Within Azure, administrators can upload custom certificates or use App Service, manage certificates to streamline secure communication. Integrating TLS is a critical step once an app service is provisioned, particularly when custom domains are configured. This approach aligns with best practices for compliance requirements, such as PCI DSS or HIPAA. Furthermore, consistent certificate management helps ensure uninterrupted secure connectivity. Prior knowledge of app service creation, from previous studies in this course, supports understanding how TLS can be layered atop a running web application. Failing to enable HTTPS can expose sensitive information, underscoring the significance of robust certificate management. Azure App Service supports various certificate options to cater to diverse organizational requirements. One approach involves uploading your own certificates purchased from a trusted certificate authority, CA. This method grants maximum flexibility, enabling the use of branded or specialized provider certificates. Another method uses App Service managed certificates. These certificates are a convenient choice for simple hosting scenarios where a custom domain is secured with a free, automatically renewed SSL certificate. Self-signed certificates, while useful for development or testing, generally should not be employed for production workloads. Beyond standard SSL offerings, Azure also supports wildcard SSL configurations, allowing multiple subdomains under a parent domain to be covered by a single certificate. Understanding these options helps organizations strike a balance between security, cost, and ease of maintenance. Being aware of certificate compatibility guides more strategic selection when planning the deployment of an application in Azure App Service. Administrators can generate certificates from a variety of sources before uploading them to Azure. Traditional methods involve purchasing from commercial CAs, such as DG-Cert or Global Sign, which provide authoritative and trusted root certificates. Alternatively, free solutions like Let's Encrypt are popular, although they require automated scripts or integrations to manage renewals. In non-production scenarios, self-signed certificates can be generated via OpenSSL or PowerShell. For instance, using OpenSSL, you might run a command such as OpenSLREQ x509 nodes days 365 new key RSA 2048 key out mycert.key out mycert.crt when generating certificates, specifying accurate domain names, including wildcard or subdomain considerations, is important. Ensuring correct cryptographic protocols, RSA, ECC, and key lengths, 2048-bit for 1096-bit, also safeguards the application. Thorough planning around certificate creation helps minimize operational disruptions, especially when migrating certificates between environments or renewing them periodically. Once a certificate is obtained, it must be bound to the custom domain on your app service to enable HTTPS communication. In the Azure portal, administrators typically navigate to the TLS/SSL settings blade within the app service configuration. They can upload a PFX certificate, provide the password, and associate it with the corresponding domain. This process informs Azure that all incoming requests to the specified domain must be serviced over TLS. Binding is especially important for multi-domain certificates or wildcard certificates that protect multiple subdomains. Proper certificate binding ensures that requests are encrypted end-to-end, catering to security best practices. It is also necessary to confirm that custom domain settings point the DNS records, name, or a record to the Azure App Service. Once binding is complete, administrators can validate the HTTPS connection, ensuring the certificate details and expiration dates match expectations. Configuring a custom domain is a prerequisite to applying a custom SSL certificate. Typically, an administrator updates the domain's DNS records to map the custom hostname to the Azure App Service endpoint. With an A record or name record in place, the domain is validated through the Azure portal. Once verified, the domain can be assigned within the settings of the app service. Establishing HTTPS immediately after domain assignment ensures that all visitor traffic is encrypted, satisfying compliance obligations. Furthermore, it fosters trust by revealing a lock icon in browsers and eliminating security warnings. For staging or testing, subdomains can be assigned to different slots, each with distinct certificates if needed. This adds flexibility in dev test scenarios where teams continuously deploy new features. Considering organizational policies and best practices, administrators typically enforce HTTPS-only traffic once custom domains are in place. Azure's App Service managed certificates simplify the process of securing custom domains. Instead of uploading and manually renewing a certificate, administrators can request a free certificate directly through the App Service blade. These certificates are domain validated, so they must align with the custom domain configured in the App Service. They renew automatically, eliminating the burden of tracking expiration dates. However, these managed certificates typically cannot be used for wildcard domains, nor do they always meet advanced compliance needs that require extended validation. Despite these limitations, they are invaluable for small-scale solutions or scenarios where custom brand identity is not paramount. By streamlining certificate creation, Microsoft helps ensure that new or experimental services maintain HTTPS without incurring additional expenses for certificate management. This approach is especially beneficial in agile environments with frequent code updates, where maintaining robust security is still a priority. A key component of certificate management is renewal. Failure to renew before expiration can result in site unavailability or browser warnings. For certificates purchased from a commercial CA, scheduling reminders is vital. Tools like Azure DevOps or other CI/CD pipelines can incorporate scripts that check certificate expiration dates. For Let's Encrypt, specialized solutions, such as the Let's Encrypt extension for Azure or third-party automated scripts, manage the challenge response mechanism needed for certificate renewal. Azure Key Vault can also store your certificates, offering robust policy checks and integration with App Service. Managed certificates take care of renewals seamlessly, providing an advantage to smaller applications or proof-of-concept deployments. Ensuring timely renewal fosters a continuous user experience and avoids brand damage. In complex environments, employing a centralized certificate manager or key vault-based strategy can help maintain consistency and minimize manual oversight across multiple applications. Azure Key Vault plays a significant role in securely storing and managing sensitive assets, including SSL certificates. By integrating Key Vault with App Service, administrators reduce the exposure risk of certificate private keys. Through the Vault's access policies, you can control which Azure resources can read or update the secrets. This approach aligns with the principle of least privilege and helps meet regulatory standards. Once a certificate is stored in Key Vault, an app service can reference it directly, eliminating the need to download a copy of the certificate. Additionally, Key Vault supports auto-renewal for supported certificate authorities, streamlining updates. Enabling managed identity in the app service can help handle authentication to Key Vault dynamically. This architecture is particularly beneficial in large enterprises with numerous applications, as it centralizes certificate oversight and ensures standardized key rotation policies while aligning with DevSecOps best practices. When configuring certificates and TLS for app services, abiding by security best practices is critical. Organizations should mandate TLS version 1.2 or higher, as weaker versions can be susceptible to cryptographic vulnerabilities. Maintaining strong cipher suites ensures robust encryption. Additionally, restricting inbound traffic to HTTPS helps enforce secure communication, especially when dealing with sensitive data like payment information. Employing automatic renewal processes mitigates the risk of expired certificates that can break user trust. Using role-based access control, RBAC, for certificate uploads, and secret management ensures that only authorized personnel can modify or deploy certificates. Encrypting data at rest by storing certificates in Azure Key Vault reinforces security at multiple layers. Monitoring and alerting on certificate events through Azure Monitor or third-party security solutions offers proactive insights into potential misconfigurations or anomalies. These measures collectively safeguard the application's confidentiality, integrity, and availability. In more advanced scenarios, app services may be integrated with networks where additional security considerations come into play. For instance, organizations might deploy an app service environment, ASE, for isolated hosting, ensuring traffic remains within a specific virtual network. Even in these private environments, TLS remains significant for encrypting traffic, especially when data flows externally. Configuring internal and external ingress points requires thorough management of certificates, ensuring that each endpoint is properly bound. Some setups employ reverse proxies or web application firewalls, WAF, which offload TLS termination before traffic reaches the app service. Certificates must be installed on the WAF to decrypt traffic, and re-encryption might be applied for onward communication. Understanding how private connectivity interacts with TLS helps administrators maintain consistent encryption across the entire path, reducing exposure to man-in-the-middle attacks. Proper certificate placement at each network layer ensures robust coverage. Problems with certificate configuration can arise in multiple ways. A frequent issue is incomplete domain validation, where the DNS record does not properly map to the app service name, preventing certificate binding. In other cases, the certificate file may be misconfigured or corrupted, leading to an import failure. Inconsistent SSL settings, such as referencing an older TLS version, might cause some browsers to throw warnings or block access. Checking the site's SSL Labs report or browser console logs can provide valuable diagnostic information. When using Key Vault integration, verify that the correct access policies are in place so the app service can read the secrets. Occasionally, domain-level or network-level caching might delay the propagation of new DNS settings, so waiting a few hours could resolve validation problems. Systematic troubleshooting that follows the path of DNS, certificate validity, and HTTPS configuration helps isolate and rectify most common challenges. To configure certificates and TLS for an app service, administrators can follow a structured approach. Start by securing a certificate through a trusted CA, a free provider like Let's Encrypt, or by leveraging Azure's managed certificates. Next, add a custom domain to the app service, ensuring DNS mapping with name or records. In the TLS/SSL settings blade, upload the PFX file or select the managed certificate. Assign it to the custom domain using the binding feature and verify that the protocol is set to HTTPS, redirecting HTTP traffic where necessary. Optionally, store certificates in Azure Key Vault for centralized control. Then, test your application by navigating to the HTTPS endpoint, validating the certificate's details in the browser. Maintain a record of certificate expiration dates, even if using automated renewals, as a fail-safe. This process ensures a seamless transition to secure connections and fosters user confidence. Some advanced scenarios require layering additional functionality atop standard TLS configurations. For multi-tenant architectures that host numerous applications, administrators can leverage wildcard certificates to minimize overhead. In multi-region deployments, traffic managers or front doors can handle SSL termination at the edge, while the backend remains protected through encrypted channels. App service environments support advanced routing rules, enabling an organization to set up custom TLS policies or enforce strict compliance rules for industries like finance or healthcare. For internal enterprise tools, certificate pinning offers extra protection by ensuring the client trusts only specific certificates. It is also possible to integrate advanced hardware security modules, HSMs, if working with specialized cryptographic requirements. Through these granular configurations, Azure App Service meets varying security demands without sacrificing agility. This modular approach allows administrators to scale and adapt certificate strategies according to each application's complexity and compliance context.